How do I share this URL? Whatever. Well, I'm going to do a little live stream as I'm recording here, so I'm going to start the recording, and then this will be what will be available later, because that's enough. All right. Weird. Hey everyone, I'm going to keep recording here. We're at part 2, number 11, find the perimeter of a rectangle with the given length and width. Be sure to give the correct units as well. We're finding perimeter. So we're going to find the, there we go, we're going to find the perimeter of this. So our formula for perimeter is twice the length plus twice the width. So for number A here, that's going to be 2 times 12 plus 2 times 7, which is 24, plus 14, so that's 38, and it's a perimeter, so our units are linear centimeters. B, 4 inches by 5 inch rectangle, so that's 2 times 4 plus 2 times 5, which is 8 plus 10, 18 linear inches. And lastly, we're going to have C, which is, let's see here, 82.5 meters. So I'm going to multiply that by 2. 165 meters by 33.3 meters. Going to multiply that by 2. And we'll get 6.6. We add them up together, 165.0. 6.1312, 231.6 linear meters. Great. Next, we're going to do areas for these same values. The area of a rectangle, area, is equal to the length times the width. So for A, that's going to be 12 times 7, 84 centimeters times centimeters squared, because we're talking about an area. It's going to be centimeters squared. So for B, we're going to have 4 times 5 equal to 20 inches squared. And lastly, for C, we're going to have, let's see here, 82.5 times 33.3 24, right? So then this gets repeated again. And one more time for that last 3. And we add this all up. 5, 2, so that makes 5, 12, 17, 3, 7, 14, 3, 7, and a 2. 1, 2 decimals, 2 meters squared, 2,747 and a quarter meters squared. Great. .426, gonna open up the next file. I wasn't quite thinking. I thought there was more space. Do I want to save? No, I don't. It will be lost to the ages. Let's open this up, and this gets adjusted, and then this gets adjusted. Okay, so need scratch paper. Scratch paper for the streaming. About 5 minutes. In 3, 2, 1. On Monday, my cookie jar had 8 cookies. Over the next week, we ate 3 on Monday, 4 on Tuesday, made 36 cookies on Wednesday, ate 6 on Wednesday, ate 3 on Thursday, and ate 2 on Friday. how many cookie jars were in the cookie jar? How many cookies, pardon me, were in the cookie jar on Friday night? Okay, so we're going to have, for the positive stuff, 8 and 36, so that's 44 cookies. And then we're going to have minus 7, and then minus 9, minus 11. So that's going to be 44, right? Because I'm going to group these. And I can group all three of these. 44 minus 7, so that's 44 minus 18, or not 30, but 26 cookies. All right. And of note, I did the little, here's Monday, here's Tuesday, here's Wednesday, here's Thursday, here's Friday. I broke it up so I could go back and check. Adding up all these digits, sure, fine, easy. But saying, okay, what's the structure of this word problem? It's divided up into days. That's what we really should be thinking about. Suppose that I eat an average of 8 granola bars a week. So this is 8 bars per 1 week. If I have 20 granola bars, how many will I have left after 12 weeks? Well, this is pretty well rigged. So 8 bars per week times 12 weeks is going to be, weeks cancel out, and we're left with 96 bars. And we started with 20 minus 96. So that's either going to be a negative 76 bars, which would tell me I need 76 more, or simply none. I will have run out long before 12 weeks. I am partial to this answer. None. Okay, next question, number 15. You are going to make peanut butter fudge. Yum. You want to know how many calories are in the fudge. Boo. The fudge consists of the following ingredients in the listed amounts, and they contain the given calories. Okay, so we've got 16 tablespoons of peanut butter containing 100 calories per tablespoon. Okay, so peanut butter is 16 tablespoons times 100 calories per 1 tablespoon. 8 ounces of butter containing 100 calories per ounce. 8 ounces times 100 calories per 1 ounce. See, I'm writing it with the division because I have a feeling that there's going to be something tricky happening here. And then, let's see here, 16 ounces of powdered sugar containing 110 calories per ounce. Oh, maybe not. 16 times 110 per 1. Sticking it over 1 would be something like 16 tablespoons with 200 calories per 2 tablespoons, which if you look on the back of a jar of peanut butter is what it tends to be. How many calories are in the entire batch? Well, this is going to be 1600. This is going to be 800. And this is going to be, let's see here, 0, 6, 7, 1. 1,760. So then we're going to add them all up. 0, 6, 14, 21, and 4. 4,160 calories. With a capital C, pardon me. Capital C calories. If the recipe makes 64 servings, find how many calories are in 1 serving. Round your answer to the nearest calorie. Okay, so that means we're going to divide by 64. And that'll get me how many calories are in 1 serving, calories per serving. Alright, now I can either just straight up divide, or I could try to be tricky with the fractions. Let's just straight up divide. The fraction 4,160 divided by 64 would reduce, but we don't need to complicate things. 8 doesn't go in, 7 doesn't go in, 6 will go in, I believe. So 24, 36, so that's 38. We subtract to get 10, oops, 11 there. So that's 2, 3, and 0. So then 320. I believe 5 is the correct amount there. 20, 32, 0. So that tells me for part B, 65 capital C calories per serving. Awesome. Next one. We're into chapter 2. We're solving for x. I'm going to take x minus 11 and set it equal to a negative 3. To get our solution, we add 11 to both sides. Remember, it's always both sides. And when we do, we'll have 11 minus 3, or 8, as our solution. For number 17, I'm going to have 5x is equal to 210. We're going to divide both sides by 5. And that'll give us, for our answer, x is equal to, let's see here, 5 goes into 20 4 times, and it goes into 10 twice, 42. Last, number 18, we're going to have 4x minus 8 is equal to 4. First, we add 8 to both sides, and we get 4x is equal to 12. Then we divide, and we divide both sides by 4, and we're going to get x is equal to 3. All right, that's 3 problems done quick. Next set of 3 problems. More solving. We're going to start with number 19, and we'll have 5x minus 8 is equal to 17. Add 8 to both sides, and we'll get 5x is equal to 25. When we divide by 5, we'll get x is equal to 5. 20. 2/7 x plus 13 is equal to 3. I'm going to subtract 13, and we'll get 2/7 x is equal to a negative 10. And then I'm going to multiply everything by 7 over 2, right? The reciprocal. So we'll have x is equal to negative 10, we'll write it over 1, times 7 over 2. 2 goes into 10 5 times. 7 times 5 is 35, and we can't forget that negative sign. So we better make this negative, a negative 35. Last, 21. All right, we have 12x minus 7 is equal to 3x plus 11. Gather our x's. 9x minus 7 is equal to 11. Add 7. 9x is equal to 18. Divide by 9. X is equal to 18 divided by 9, 2. And if I wanted to, I could go back and check. 24 minus 7 is equal to 6 plus 11. I believe it is. Great. Next set of exercises. More solving. Okay. For number 22, I'm going to take, let's see here, that 2 and distribute it. So we'll get 6x minus 12 is equal to, and then we're going to distribute the 1/3, 2x minus 3. Okay. Subtract 2x from both sides will give us, let's see here, 4x minus 12 equals, the negative 3 remains. Add 12 to both sides. 4x is 12 minus 3, so that's 9. Divide by 4, x is 9/4. Great. And I didn't list the help of a calculator to check that one. For 23, I'm going to distribute the 3 and get 3x minus 6. Let's label this. This is 22, and this is 23. 3x minus 6 plus 2x equals 4x minus 6. Gather these two, so that's 5x minus 6 is equal to 4x minus 6. Okay. And now we're going to subtract 4x from both sides. So we'll get x minus 6 is equal to a negative 6. Ooh, you know what happens when we add 6 to both sides? We get x is equal to 0. Cool. And that's pretty easy to check, too. 3 times the negative 2 is equal to negative 6. Hey, yeah, look at that. Answer checks out. Last, number 24, with all the fractions. We've got what? 1/5 x minus 7/5 plus 8 is equal to 4/5 x minus 2/5. I think you guys see from how I'm writing this out, what I want to do is I want to take and multiply everything by 5, because if I do that and I multiply every term, that's how we have to do it, every term, I'll get x minus 7 plus 40 is equal to 4x minus 2. X plus 33 is equal to 4x minus 2. 33 is equal to 3x minus 2. 35 is equal to 3x. 35 over 3 is equal to x. So we use that trick. We multiply every term. And then we're able to solve as usual after we multiply every term. Woo! All right. Next set of exercises. We're going to solve x minus y minus z. Quantity divided by 4 is equal to 2w for y. And the important one here is y. I'm going to circle it. Multiply everything by 4 to get x minus y minus z is equal to 8w. Let's subtract x. So we get minus y minus z is equal to a negative x plus 8w. And then we're going to add z. You know, I think our order should be what? W, x, z. Yeah, I like that order. And then I'm going to take a look at the pattern here of the signs. They go what? Plus, minus, plus, and y is negative. Because I need to flip it over so that y becomes positive, right? Which means that these are going to go negative, positive, negative. So everything becomes y is equal to negative 8w plus x minus z. Okay, I like that. Okay. We'll handle these percentages, and I think we're going to call it a video. 68 is what percent of 200? Okay, so P is equal to 6800 over 200. Zeros drop off. We're left with 68 over 2, 34%. What number is, so what number is 55% of 140? So x is going to be equal to 140 times 55, so that's 0027. Skip a space and repeat it. 7700, so this is 7,700 over 100. Once again, these zeros are going to drop off, and we'll be left with x is equal to 77. Cool. Those are our answers. That's it for this video. Next time, part 3. It's part 3 of our review session. So a piece of pipe is 6 feet long. It's going to be cut into 3 pieces. So let's draw a little piece of pipe here. So I'm going to draw a side. We're going to go and it's cut into 6 pieces, or 3 pieces. It's 6 feet long, and it's going to be cut into 3 pieces. Great. The first piece is twice as long as the third piece. So third piece, first piece twice as long. Second piece is 3 times as long as the third piece. Great. I think we can kind of see the pattern happening right here. How long is each piece? We take 2x plus 3x plus x. We set it equal to 6, and we'll get 6x is 6. X is equal to 1. So then we have x is 1, 1, 3, 2, 1 plus. So let's not do the x. Let's just figure out 1 plus 2 plus 3, right? Oops, pardon me. Let's look at 21, but it's not. In 3, 2, 1. 2 plus 3 plus 1 is 6. This checks out. This checks out. The pieces are 1, 2, 3 feet long. Feet, feet, feet. There we go. Great. Next question. The number of blue marbles plus the number of green marbles, so blue plus green, is the number of yellow marbles. Okay. 1/4 of all the marbles are blue. So if I take all of them, I divide it by 4, I get the number that are blue. Okay. If there are 12 green marbles, compute the number of total marbles, so we're looking for all of them, as well as the number of each color, and each individual color. The first thing I want to look at here is that idea of all the marbles. That's all the blue ones, and the green ones, and the yellow ones. All the marbles. Okay. So that means we'll take blue plus green plus yellow. Oops. Over 4 is equal to blue. So blue plus green plus yellow is 4 times the number that are blue. Blue plus green is yellow, so that means I'm going to make this substitution here. I can get rid of the yellow, and then it'll be a help. So 2 blue plus 2 green is 4 blue. Now, it's just that pesky green that we've got to deal with, but I can't delete it. Alright, fine. Every once in a while, things just don't go quite like we'd hoped they would. I think this is one of those cases where things aren't quite going where they thought they would. I'm going to wrap up this chapter and then we'll call it in 3, 2, 1. Cheryl is 3 years older than Mary. Use C for Cheryl's age and M for Mary's age. So we're going to write an equation describing Cheryl is 3 years older than Mary. Solve for C. Okay, so here we go. We're going to do 3 years older, so Cheryl is Mary's age plus 3. Great. I'll solve it for M. C minus 3 is equal to M. Great. Cheryl is between 35 and 40 years old. Well, she's more than 35. And she's less than 40. Now we're going to describe Mary's age. Well, C is M plus 3, so 35 is less than M plus 3 is less than 40. So that means 32 is less than M is less than 37. Hey, look at that. Great. One more set of exercises, and that'll wrap up the Chapter 2 material, and we'll call it a video. We're going to start with number 32 here. 11x minus 8 is greater than a negative 52. This is the one where there was a typo in the solutions. We're going to add 8 to both sides, get negative 44. Divide by 11 and get negative 4. Yes, that should be negative. Let's take a look at number 33. 5 minus 3x is greater than 23. So negative 3x is greater than, let's see here, 18. And then x is going to be less than negative 6. Because when we flip the negative sign over, we've got to flip the direction of that inequality. This is 33 and this is 32. Okay. Last 34. For number 34, we've got x minus 38 is less than 5 times x plus 2. Alright, so x minus 38 is less than 5x plus 10. So negative 38 is less than 4x plus 10. Negative 48 is less than 4x, so negative 12 is less than x. What's that? You want this in set builder notation? This is a set of all x such that x is greater than or equal to negative 4. This is the set of all x such that x is less than negative 6. And this is the set of all x such that x is greater than negative 12. Interval notation, negative 4 comma infinity, negative infinity comma negative 6, negative 12 comma infinity. Great, and I think that does that for this video. Great job, everyone. We'll wrap this up next time.